In this project, we have to create an autonomous boat, which will have also a manual override. And a manual override will only occur whenever there is failure of our program. For instance, when our boat is in the middle of the waters or in the ocean, and there is a failure in the program, then a manual override will take place where a user can take full control of our boat when is in any place using the LabVIEW tool that we use. The LabVIEW will have an interface for a full control of the boat. It will have an interface to show the sensors information, to display the speed of the boat, the direction that the boat is headed, and the knobs to control the boat from right to left in the LabVIEW. So the first thing we are going to do here is to have all the components that we will require in the wiring. Since we are doing the virtual wiring, we will require a platform for the wiring system. So I choose a Tinkercard platform, which is a software application as a service that provides a platform for wiring. And the first thing is to log into the platform or create account, and it will provide an interface for wiring. I've wired all the components here, and it's concealed. The first thing after wiring, we can write a program, and in this I have written the code. I will define all the pins, the pin ports, and where the connection has been done from the Arduino board to all the components to the microchip. And also we have also an interface for adding basic components whenever we want to add more components to our wiring. And if you want also to view as a schematic view of our program, of our wiring, we can do that. And still here we can have a list of the components that we have done during the wiring, and their quantity, have the name, the quantity, and the components. And if you're still missing some, we can still add some of them. Here is a list of the components that I've used for wiring of the system, including the bumper, the master and the slave, the ultrasonic sensor, the microchip, and the rest of the components. Yeah, these are the components in the diagram. We have the 9V battery, we have the left and the right motor. It will be propelling the propellers. We have the breadboard that have used to mount the components, the microchips, and the potentiometer, Arduino board, and then also have the ultrasonic sensor and the bumper. Then you have the master, the master, of course, the master Arduino board that will be used for programming. These are the equipment that will be driving our system. If we do the simulation, we can see the simulation has started and the code is running successfully. There are no bugs and there is no error in this code. Then we can stop this simulation and go to our LabVIEW. Okay, yes, here is our LabVIEW interface to control the autonomous boat by inputting values to control the Arduino. Also for manual control, you have the interface to input the number characters and the characters to be displayed in the in the ultrasonic sensor, the bumper sensor, and also the potentiometer. We also have the instruction for our Arduino board, the input values that are programmed in the code, and then in our interface you have the manual. If you want to start the manual, you can press the button, and if you want to do automatic turning off and turning on in a manual way, we can do in the interface. And also in the left side, you have the sensor control panel. We can have the view of this ultrasonic sensor, the bumper sensor, and the potentiometer. And also you have direction control, the speed control of the motor. As I said earlier on, the speed control, you can control the speed by moving the arrow to the right, and it will increase the speed of both of the two motors. And then the direction of the motor control, you can control the speed of the right motor and the left motor. And when you control the speed, it will change the direction the of the two. Here we can view the block diagram of our system in the LabVIEW.